My name is Darren Patey of the Water Resources Management Division. Today I'll be talking about chlorine disinfection and why it is necessary to have detectable chlorine residual readings in all areas of the distribution system, including dead ends or end of lines. I'll also be providing some solutions that can be considered if a community is having issues maintaining the end of line chlorine residuals. The main goal for drinking water system operators is to provide clean and safe drinking water. Disinfection is the main tool that water operators can employ to destroy or inactivate harmful pathogens from drinking water. This is required primarily due to the health risks posed by water-borne pathogens present in source waters or that may enter the water distribution system downstream of the treatment facilities. The presence of microorganisms like Giardia and E. coli in the water supply can cause illness if the water is not effectively disinfected. Pathogens can be introduced into the water distribution system in many ways, including through water main breaks, during construction that impacts water mains, system cross connections, or an introduction of a contaminant at the water supply source. That's why it is important to have residual chlorine throughout the system to provide that security. In the province of Newfoundland and Labrador, all public water systems must be disinfected. Chlorine is the most common form of disinfection used in Newfoundland and Labrador. Water system operators must ensure enough chlorine is added to the drinking water to achieve primary disinfection standards and to ensure detectable chlorine residuals are maintained throughout the distribution system. The drinking water treatment standards for Newfoundland and Labrador are available on the Water Resources website. This publication outlines the requirements for primary and secondary disinfection. The objective of the drinking water treatment standards is to reduce the risk of illness and other health effects attributable to drinking water supplied through public drinking water systems. Effective chlorine disinfection is confirmed by testing chlorine residuals throughout the distribution system. Chlorine residual is the concentration of chlorine remaining in the water after a given contact time in the distribution system. It is very important for system operators to test and record free and total chlorine residual readings at the start, middle, and dead ends of the distribution system every day. Chlorine residuals are often measured with a colorimeter. A training video on how to conduct chlorine residual testing is available on the Water Resources Management Division YouTube channel. Once you have collected and recorded your chlorine residuals, you can compare them to the following guidelines. At the first home or customer after the chlorination building, free chlorine residuals should be at least 0.3 milligrams per liter with a contact time of 20 minutes or equivalent CT value of 6. For the rest of the distribution system, you should try and achieve a detectable level of free chlorine residual. To be on the safe side, communities should strive to get 0.1 milligrams per liter at the ends of their distribution lines. The training webpage of the Water Resources Management Division website includes standard operating procedures, including one that addresses CT factor calculation guidelines. If these requirements are not met, the community should contact a regional digital government of service NL office to determine if a boil water advisory is needed. Water distribution systems in many Newfoundland and Labrador communities are treed or branch type configuration. These systems contain long linear sections of water main that leads to a dead end or multiple dead ends. In order for the chlorine residual to reach all points in the water distribution system, there must be enough flow throughout the system to move the chlorine from where it is injected at the chlorination building to the end of the distribution line. Residents and businesses using water is normally how water flow is created throughout the distribution system. But at the locations where water is stagnant because of low water usage, there can be a loss of chlorine residual, as well as a buildup of sediment or biofilm formation in the piping. It is common for water users at dead-end locations to complain about taste, odor, and water discolorations, which can be due to the sediment and biofilm formation. To expand on that, now we'll go into more detail with possible explanations for having low residuals at the end of lines. There are several reasons why a system may not have sufficient chlorine residuals at a dead end. Some common explanations are low water flow. As water ages in a distribution system, the chlorine compounds break down and no longer provide the same level of disinfection. Low water flow could be due to a variety of issues, including lack of users in that area of the distribution network, poor distribution system design, seasonal changes in water use, and overall decline in water system use or number of users. Another possible explanation could be that there's not enough chlorine added to the water to meet chlorine demands. In this case, the chlorine dosage is too low to meet bulk water and pipe wall chlorine demand. This is particularly common for certain types of pipe like cast iron or when biofilm is accumulated on pipe walls. Additionally, the applied chlorine could be expired and no longer as effective as intended. There's also the possibility that there's a leak. For chlorine dosing systems that are not flow-paced, a water main leak somewhere in the distribution system can negatively impact chlorination efforts and lead to reduced residual chlorine downstream of the leak, especially at dead ends. This is because more water is being pumped from the source due to the leak, but the chlorine dosing has not been proportionally increased. Now that we talked about the possible reasons, let's discuss some of the options you have to improve chlorine residuals at the end of lines. The first thing you should look at is increasing the amount of chlorine injected into the water. Once you have increased the chlorine dose, allow enough time for the chlorine to travel through the distribution system and then check your chlorine residuals to see if they have increased. Continue to adjust the chlorine dosage until the desired chlorine residual has been reached. If that doesn't work, you can consider flushing your water distribution system to improve the water quality at dead ends. Flushing can help remove accumulated sediment and biofilm from water mains and move stagnant water through the system. Flushing should be done during periods of low water demand and should be conducted at least once a year. However, some water systems may need to be flushed more often. There is also an existing instructional video on our Water Resources YouTube channel related to system flushing. Here is a short segment of that video which describes the ways an operator can flush their system.
There are two types of flushing, conventional and unidirectional. Conventional flushing involves simply opening fire hydrants in the system to move a greater volume of water to hydraulically remove sediment built up in the pipes. Unidirectional flushing is a method of flushing where the operator controls the direction of flow in the system through the opening and closing of system valves to ensure all sections of the system are being flushed and optimal flows and velocities are achieved throughout the flushing process. By closing valves in a predetermined sequence, the operator may be able to increase pressure in the line and achieve appropriate velocity to ensure pipe walls are scoured and sediment is removed.
If a community does not presently have the ability to execute a flushing program, some infrastructure upgrades can be considered. First, you should consider the installation of hydrants to flush your system at the necessary locations. This can be either a standard fire hydrant or a less expensive flushing or post hydrant. In certain situations, automatic flush valves may be more effective than hydrants. In locations where frequent flushing of lines is required to obtain an adequate chlorine residual, automatic flush valves can be installed to enable the movement of water at the location on a regular frequency. Automatic flush valves can be set to discharge a set amount of water on a time basis. However, for both manual flushing using a hydrant or a discharge from automatic flush valve, it is important that the discharge line must be carefully located to ensure chlorinated water is discharged to a suitable location. Otherwise, dechlorination of the water discharge may be required. Automatic flush valves make it easier to frequently flush systems and do not require operators to manually conduct the flushing. However, automatic flush valves are more expensive than installing hydrants and can be more complicated to troubleshoot or fix if issues come up. Another upgrade that could be considered is the addition of chlorine booster stations. Chlorine booster stations are used to inject additional chlorine into the water at a point within the distribution system. A chlorine booster station could be considered when chlorine residuals are low and cannot be adequately improved by increasing chlorine dosing at the beginning of the system. Additional chlorine would be added at the booster station to increase the amount of chlorine at the end of the line. Installing a chlorine booster station is the most expensive option we've covered here today, as it involves constructing an additional chlorination building with all the necessary chlorine dosing equipment. It would also need to be monitored just like the first chlorine dosing system, increasing the workload for the water system operator. I hope you have found the information we went over today useful for the operation of your community's water system and specifically for improving chlorine residuals at the end of your distribution lines. For more information on the operation of your drinking water system, contact the operator trainer for your region or visit the department's website.